Across the vast, silent tapestry of the cosmos, amidst billions of galaxies and trillions of worlds, there lies a question that echoes through every human mind. Are we truly alone? If they exist, out there among the countless stars that dot our night sky, would they share our form? Two eyes to witness the universe, two hands to shape their destiny, a face that somehow mirrors our own humanity. Or could life take on a visage so utterly alien, so profoundly different, that it would transcend every definition, every expectation we've ever held about a living being? This profound inquiry, stretching the very limits of our imagination and scientific understanding, is precisely what we aim to explore today. For centuries, the question, are we alone in the universe, has been a haunting mystery. Yet, in the last decade, modern science has drastically reshaped the landscape of this very question, shifting it to how alone are we, really? This paradigm shift comes thanks to revolutionary telescopes like Kepler and TESS, which have unveiled a startling truth. Planets are incredibly common across the cosmos. Observational data now indicates that almost every star we gaze upon, from the nearest to the most faint, likely hosts its own planetary system. Even more astonishing are the implications. Of the billions of stars in our Milky Way galaxy, recent estimates suggest that billions of rocky planets likely reside right within their host star's habitable zone, that precise region, neither too hot nor too cold, where water can exist in liquid form on their surface. Water, as we know, is the primary key to life. If the fundamental building blocks of life are so incredibly abundant, and the right environmental conditions are also plentiful everywhere, then by the very principle of probability, it would be exceptionally strange if life only emerged and evolved in one single tiny corner of this vast cosmos, wouldn't it? Often, when we imagine beings out there, our minds drift to strange and unpredictable forms. Yet there's a fundamental concept in Earth biology that might offer surprising clues about how intelligent life in other galaxies could appear, and that is convergent evolution. Simply put, it's the idea that genetically very different species, even those without a close common ancestor, can develop remarkably similar traits or body forms. Why? Because they face similar environmental problems and find optimal evolutionary solutions. Imagine a dolphin and a shark. One is an air-breathing mammal, the other a gill-breathing fish. Yet both possess sleek bodies, efficient fins, and incredible swimming abilities. The evolutionary pressure to be fast predators in the ocean has shaped them to be similar. Another astonishing example is the octopus eye and the human eye. Despite evolving separately and within different animal kingdoms, both possess complex structures with very similar lenses, irises, and retinas. This occurs because their primary purpose is the same: to gather light and form clear images in aquatic or terrestrial environments. So, if this principle holds true across the cosmos, imagine the implications. If alien beings on other planets face challenges similar to those that shaped us, such as gravitational pressures, the need to find food, communicate with one another, and most crucially, develop technology to build civilizations, then it's highly plausible they would discover similar anatomical solutions: legs for mobility on solid surfaces, hands or flexible limbs for tool manipulation, or sensory organs concentrated in a head to process environmental information. This principle of convergent evolution forms a strong basis for much of our speculation about the physical forms of intelligent aliens. It suggests that while the universe is boundless in its possibilities, there are physical constraints and efficiencies that may push life, wherever it arises, towards certain forms. Let's start with the scenario we understand most easily, which also appears most frequently in science fiction: if they resemble humans. Intuitively, we often imagine alien beings with two arms and two legs, even with faces we might recognize. However, while it's highly unlikely they'd be exactly like us, without the same nose, ears, or hair, some basic features, which we consider human-like, might universally reappear. But why? Take bipedalism, or the ability to stand and walk on two legs. On Earth, this evolutionary innovation freed our ancestors' hands. These free hands became crucial, allowing them to use and create tools, carry food over long distances, and communicate with complex gestures. For a civilization aiming to achieve advanced technology, the ability to precisely manipulate the environment is a primary key. Therefore, hands or some kind of flexible manipulative organ with nimble and precise digits might be an evolutionary imperative regardless of their planet's environment. Then there's the head feature. The clustering of primary sensors, like eyes for vision, auditory organs for sound, and a sense of smell, concentrated at one end of the body, facing the direction of movement, is a highly efficient design. This allows for rapid and coordinated processing of environmental information, vital for navigation, foraging, and avoiding danger. Even bilateral symmetry, two mirrored sides of the body, is an incredibly efficient design for directed forward movement. Imagine navigating complex terrain or interacting with a three-dimensional world. Therefore, a creature with one head, a defined torso, and multiple balanced limbs might be a highly optimal and efficient design across various types of planets and environments. These features, which we often perceive as human designs, might actually be the most efficient evolutionary solutions to universal challenges faced by intelligent life wherever it may arise in the cosmos. But what if life out there is completely unbound by the organic limitations as we understand them? What if they are far stranger than we could possibly imagine? It's entirely possible that intelligent life doesn't have to be carbon and water-based. Imagine silicon-based creatures on incredibly hot planets, relying on molten lava as their blood. Or could there be life forms living in the atmospheres of gas giants, swimming through oceans of methane clouds, completely untethered to a solid surface? In fact, we might not even be looking for individuals. It's possible that extraterrestrial consciousness is a collective intelligence, a multitude of simpler organisms like a super colony of ants or an underground fungal network that collectively achieves extraordinary levels of intellect. And let's not forget the evolution of technology itself. A civilization might reach a point where they shed their biological bodies entirely, transforming into artificial intelligence or robotic entities. Their form would then be dictated by computational efficiency and durability, no longer by biological natural selection. In this scenario, they might not even need sensory organs or limbs like ours, as information could be exchanged digitally or through energy fields. Their forms would truly be freed from the constraints of flesh and bone. Beyond divergent evolutionary paths, the environment will also be a primary determinant of life's form. Gravity is a key factor, On planets with much higher gravity than Earth, living beings might evolve to be shorter, stockier, with incredibly dense and strong bone structures to support their weight. Conversely, on planets with very low gravity, we might see creatures that are tall, slender, or even possess structures that allow them to float or fly easily in a thinner atmosphere. What about the atmosphere? If the atmosphere is very dense, perhaps there are creatures that evolve to be like balloons, using gas to float. If the atmosphere is toxic to us, naturally, their respiratory and biological systems would be vastly different. Temperature and energy sources are equally important. Life on extremely cold planets might have natural antifreeze in their cells, or bodies designed for long hibernation. On hot planets, they might possess internal cooling systems or a nocturnal lifestyle. Every world will be a unique evolutionary playground, giving rise to life forms perfectly suited for their environment, even if that means shapes utterly bizarre to the human eye. So, will aliens resemble us with 2 legs and 2 hands? Or will they be energy composites or crystalline beings breathing methane? The answer, of course, is we don't know. All of this is speculation, yet speculation grounded in the best scientific principles we currently understand. This unknowing isn't a weakness, it's a strength. It fuels our curiosity, pushing us to build bigger telescopes, send probes further, and listen more intently. Perhaps one day a signal will arrive. Or future telescopes will reveal the surface details of an exoplanet, showing us the beings living there. And whether they have 2 legs or 100 tentacles, whether they are made of carbon or silicon, that encounter will change our understanding of the universe and of ourselves forever. What do you think? If you could imagine other intelligent life forms in this universe, what would they be like? Share your thoughts in the comments below. Don't forget to like this video if you enjoyed it and subscribe for more cosmic explorations. See you on the next journey.